So, in this lesson we are going to continue the inventory management. I don't have the game completed yet, and every week I'm testing what to do as the next step. I spent this week testing different approaches to the inventories interface, but it implies modifying a little of what we already did before. Nothing too serious, but different in some scripts. We are going to start by modifying the scripts that need to be improved. First, let's open the Items prefab and remove the Item Properties component. We are going to centralize this information in just one scriptable object. Inside the Scriptable Objects folder, create a new script and call it ItemDatabase. This scriptable object will contain kind of the same information as in the Item Properties script, but also other useful information. We start by creating an array of items and building the struct that composes that item. Inside, we add a reference to the game object itself, another to the bottom sprite we will use later in the user interface, and the same information about the energy for each item. As you may notice, the name is no longer here. We are going to use the name of the prefab and the name of the sprite as the name of the item. Once done, create the scriptable object and add 6 items to it. Because we already have the lithium and the plutonium, we can drag those prefabs here and change the energy values. You can also delete the item properties script file because we will not need that anymore. You will get an error in the console because that script is referenced in another script. Double-click the error and change the line to string item name equal empty and save. So far so good, we don't have the rest of the assets yet, so let's continue with other modifications before adding new stuff. The RoboInteractions script and the inventory script are extremely dependent on each other and need to exist in the same game object to work correctly. Also, the function of the RoboInteractions is only to communicate with the inventory, and for that reason, maybe it is easier to add the function directly inside the inventory instead of having to deal with two scripts. So, open both and copy the onTriggerEnter method from the interactions to the inventory. You can put it anywhere inside the class, but outside of the other methods. I will put it after the start and before the addItem method. We also need to change how the addItem is called, because we don't need the reference to the inventory anymore. We are inside the inventory, so we can call the addItem directly. This means delete the inventory dot from the call. We are also going to need the reference to the name of the tag, so just copy the variable here. Now the inventory is autosufficient and should work alone. This means you can go to the Robo prefab and remove the RoboInteractions component and also delete the script from the project panel. If you run the game, everything looks okay, but if you look closely, the items don't have the correct name and the limits are not working. This is because the inventory script doesn't have the information about the items anymore. We delete the files. So let's add a different way of referencing those items' names. We are going to use the name of the sprite to set the name of the item. We should have discipline and maintain our project organized. This means that the lithium game object will be based on the lithium sprite. All the names need to be the same and accurate. This will make our job easier. In this case, if we have more than one lithium, the name of the object is different because of the suffix. So, We cannot use it as a reference, but the sprite name is always the same. Yes, we could have an item properties as we did before with the name of the item, but it's just duplicating this information. So why can't we just use the sprite name as the name of the item? Well, we can, and it's easier to detect on collision because there is no suffix in the sprite name. So on the line where we were looking for the item properties to get the name, we are now going to look for the sprite name instead. And that's it. We have a trigger collision. We pick up the other object, get the sprite renderer component, and read the name of the sprite. Now we have the name of the item because it is the same as the name of the sprite. Running the game will be the same as before. The items have the correct names, and the add item method is respecting the limits. All the needed modifications are done, so we can start to build the interface. So, zoom out a little until you see the camera and add a new empty game object. Call it items and reset the position. Now pick all items and drag them inside. Do the same to the nature elements. This is just to keep the scene clean and organized. Eventually, we don't need to care about this on runtime because the player will never look at the hierarchy. Anyway, back to the inventories interface. Start by downloading and replacing all the assets in your project with the new ones on the zip file. I had new stuff and update some old sprites. On a side note, if you update your assets, Unity will pick them up directly. This means you can improve your graphics or add more stuff to the game without breaking the project. You just need to remember that you cannot change the location of the old assets, nor the name or the type or the size of the file you are updating. So now you go to the sprite editor of the item element's main sprite and add the following sprites: iron, glass, gold, copper, and then the button images for the interface: button iron, button plutonium, button lithium, button glass, button gold, and button copper. Notice that the size of the button's sprite needs to be exact and the same in all buttons. The size is 180 by 180. We also have an empty button, the panel for the inventory, the panel for the health, and this empty text box. This one has 220 pixels by 1220, and this one 220 by 550. These panels should go against the end of the screen, and that's why I'm cutting the sprite with this rectangle. Apply and return to Unity. To create the new items, we can just duplicate 4 times the plutonium prefab by pressing Ctrl D. Change the names according to the new elements and edit them by double-clicking the prefab to change the sprite and adjust the collider. Once done, exit the prefab editor by clicking on this left arrow at the top of the hierarchy panel. If you drag the prefabs to the scene and run the game, you will be able to pick them up as the others. The names in the inventory are the same as the names in the sprites. Now that we have all these new assets for the inventory, select the ItemDatabase scriptable object and fill the fields with the correct information. I'm just keeping the alphabetic order, but it's not important. Once done, we have everything ready to start scripting the inventory user interface script. Create a new script and call it InventoryUI. This will write on the inventory's interface the data we need to show to the player. Create a new empty object, call it UI, and reset the transform. Drag the script there. Edit the script and add, using Unity Engine UI and using TM Pro. These namespaces have the necessary functions to use the canvas and the text mesh pro. Now let's add a reference for the character and another to the inventory script. Serialize field, GameObject robot, inventory, inventory. To make sure this works, we need to get the inventory component from the robot. Inventory equals to robot get component inventory. We will not update the UI every frame. It is a waste of power to maintain the same information most of the time. We will instead call a method to update once, and we can call it every time we pick, lose, or use something. In other words, we update the interface only if there is something new to show. To do that, we will change the update method to public void update UI and eventually call it from the inventory script. We can make sure the interface will be updated at least once in the beginning by calling this in start. Update UI, read the name and count on each slot, and set the interfaces button according to that information. We need to change the start method of the inventory to awake because it needs to happen before the first update of the UI. The start method happens at the same time, more or less, in all scripts. So we need to prepare this first and then we update the UI later. So this one goes awake, and when the update UI calls for an update, these arrays are ready. In order to test this script, we actually need the interface in the scene, so let's quickly build an interface. In the hierarchy panel, create a new canvas. As you should remember from lesson 3, the canvas needs some settings to work properly. Set the render mode to screen space camera. Drag the camera to the render camera field. Set the UI scale mode to scale with screen size and give a reference of 1920 by 1080. Adjust the match to height and it's done. Now inside the canvas, right-click on it, we are going to add a panel. Call it Inventory Panel, and in the rect transform, set the anchor to mid-right and the anchor pivot to x1, y 0.5. Make sure the position is 0, 0, 0. Adjust the width and the height to the half of the inventory panel sprite. So half of 220 is 110 and half of 1220 is 610. Drag the inventory panel sprite to the source image and remove the transparency in the color field. Now, inside the panel, create a button. Because it uses the Text Mesh Pro, you need to import TMP. You can import both. Once done, set the width and height to 19 pixels. Open the button object and reveal the text object. In this text object, set the anchor to bottom center, height to 40, and pivot anchor to 0.5 by 0. Also make sure the position is 0, 0, 0. Set the font size to 12 and align to the center bottom. We need to set the font, but you can just use what you have in your system. To add a font, you need to put the font files inside the project folder. You cannot use them directly. Text Mesh Pro needs to, let's say, create a texture for the font. To do that, you need to open the Font Asset Creator from the Text Mesh Pro menu, drag your font to the source font file field, and hit Generate Font Atlas. Once done, save the font atlas in the same folder with the default name. Do that for all the fonts you have. Now return to the scene and change the font of the button to Orbitron Medium. Go back to the button object and set the empty button as the sprite. The button is done, but now we need 5 more buttons. Set the Y position of the button to 250. Change the name to slot space open parenthesis 1 close parenthesis and duplicate the object 5 times. You should have 6 buttons now, but all in the same position. The space between anchors is 100 pixels, so select the number 2 and change the position Y to 150, the number 3 to 50, the number 4 to minus 50, the number 5 to minus 150, and the number 6 to minus 250. The UI canvas should be in front of everything, so go to the canvas component and set the order in layer to 10. The importance of the anchor points is this. If your game is being played in a device with a different aspect of screen, the interface keeps the position. For example, a regular PC screen is 16 by 9, but the Steam Deck, for example, is 16 by 10. You can see that even when I change the aspect of the screen, the inventory stays in the correct location, at the right of the screen. Actually, the shape of the screen is not really important. The anchor is at the right, period. Now that we have the interface, let's finish the code in the script to update it. Let's set the variable to hold the button's image and button's text. Serialize field, image array, button icons, and serialize field tmp underscore text array, button text. These are arrays that will have the buttons in the correct order. By default, the inventory is empty, and when we have an empty slot, we need an empty sprite. So let's add the reference to that. Serialize field, sprite, empty icon. At last, we need the information about the items sprites for the buttons. That is in the database, so serialize field, ItemDatabase, ItemsDB. Save, return to Unity and set the variables. To set all the array items at once, lock the inspector, select all objects and drag them to the name of the field. Don't forget to unlock at the end. So, once again, to update the interface, we will need to swipe through all the interface slots, read the name and count on each slot, and set the interface button according to that information. Let's then make a loop to go through all the slots. For int slot equals 0, slot lower than inventory.items.length, slot ++. Every time we run a slot, we set the variables to the default names. Prepare the variables to send the data to the interface. String final text equals 0 and sprite icon equals empty icon. Then we get the information from the inventory script, set the variable data to the same data as the inventory script, and eventually, at the end, send the information to the button's image and text. Button icons slot.sprite equal icon, and button text slot.text equal final text. If we save and run the code, we will see the inventory being set to empty. we can walk and pick up items. They are being added to the inventory, but the UpdateUI method is only setting the empty slots, not the used ones. We are not yet triggering the update every time we add an item to the inventory. So let's return to the script and use the slot number to also get the inventory slot item, but only if the slot is not empty. So if inventory.items slot.name is not equal to empty, we swipe the database. For int item equals 0, item lower than itemsdb dot items dot length items plus plus. And why do we need to read the database? Well, to find the object with the same name as the name in the slots inventory. Remember, the inventory has a string as a name, and we need a sprite for the button. Finally, we test if the name match. If we find in the database an object with a name equal to the name in the inventory, we set the icon to the one saved in the database, and we set the text with the name and the count saved in the inventory. So to recap, every time we update the inventory interface, we go to every slot that is not empty and check the item name to the ones saved in the database until we find the one where we are going to extract the sprite to use in the button. We also use the same index to get the correct count to write in the text field. Save and go to the inventory script to add the command to trigger the update. To do it, we need a reference to the InventoryUI script, serialize field, InventoryUI, InventoryUI. And at the end of the add item method, we just call the update in the InventoryUI. InventoryUI.updateUI, open close parenthesis, semicolon. In Unity, drag the UI to the inventory field in the robo in the scene and run it. Everything looks fine, so let's now build a panel to show the robo's health. Go to Canvas and add a new panel. This one will be on the left side. So do the similar adjustments to make it stick to the left and add the sprite image without transparency. Call it Health Panel and add a Text Mesh Pro text box. Adjust the size to fit the orange box. Set the font size to 12 and the font type to Orbitron Bold. Change the color to improve visibility and adjust the alignment to center in the horizontal and vertical axis. Once done, add the UI image to the Health panel and change the sprite to the text box sprite. You can select the Preserve Aspect option and adjust the position inside the panel. Now drag the text to the image and adjust the position to make it like a title for the box. Duplicate the text and adjust the second text vertical position to put it inside the box. The maximum number will be 255, so set that as text and adjust the font size to make the number bigger. Once done, duplicate the image twice and space them evenly. Now that you have the Health panel ready, it's time to code the script to change those numbers. Create a script and call it RoboHealthUI. Inside we will need 4 references: the characters health scriptable object, and 3 text objects to write the numbers. So, serialize field, character health, RoboHealth, serialize field, TMP underscore text, energy text, serialize field, TMP underscore text, mechanical text, and serialize field, TMP underscore text, memory text. To have access to the Text Mesh Pro and use the UI, you need these libraries using Unity Engine UI and using TM Pro. Remove the start method and change the update to fixed update. We really don't need these numbers to be updated every frame. Now add a command to every text box. Energy text.text equals RoboHealth.energy times 255 dot toString f0. Mechanical text.text equals RoboHealth mechanical times 255 toString f0. And memory text.text equals RoboHealth.memory times 255 dot toString f0. The energy text will be equal to the energy value in the scriptable object, but because the numbers are from 0 to 1 and our carrot is a robot computer that works in binary, we will translate that to a 8-bit value by multiplying the levels by 255. After, we transform the numbers to a string and add this f0 argument to set 0 decimal places for the number. Now we have our energy, mechanics, and memory being counted in 8 bits, from 0 to 255. Save, return to Unity, and set all the fields with the correct objects. Add the script to the UI game object. Drag the RoboHealth and the 3 correct text objects to the fields. Now we have real-time feedback of the health state in the interface. We also no longer need this panel of the robot's health to track the numbers, so we can close it. The last thing we can program is a way to pick up the items from the inventory to use them. We are going to simulate a hand that can pick the full stack of only one item slot at a time and associate that to the mouse cursor so we can use the items. We are going to do this handling of the items in the inventory script. Open the inventory script and add a variable to hold the information about the item we pick up. Public item hand. In the awake method, we set the hand's value to empty and 0, just to make sure it starts in a predictable way. Hand.name equals empty and hand.count equals 0. Now we need to get the buttons from the interface. We can make a public method that the buttons can access to receive the number of the slot. So, public void item button, open parenthesis, int slot, close parenthesis. Save and return to Unity to set up all the buttons with this method. Select all the buttons and in the onClick field, add the robo to access the inventory to run the item button. The item button is expecting a number and all the buttons are set to 0. So go one by one to adjust the numbers to the corresponding slot in the array. Don't forget you have 6 buttons, 6 spaces, but the first one is 0. So you count from 0 to 5. Inside the item button method, the first thing we need to check is if the hand is empty. We can only pick something if we are not yet picking something. So if hand.name is equal to empty, we need to do 2 things. One is to copy the slot to the hand, which means we grab the thing. Hand equals item slot. And the second is to remove the thing from the inventory. We have it in our hand, so it's no longer there. Remove item slot. As you may imagine, this remove item method does not exist, and if you go to Unity, it will throw you an error. So let's create this method. Public void remove item int slot, and inside we just need to reset the slot information to the default values. Item slot dot name equals empty, items slot dot count equals 0, and at the end we update the UI because we remove something. InventoryUI dot update UI open close parentheses. Now save and return to Unity to test. Pick some items, select the Robo object in the hierarchy panel, and open the variables in the inspector. As you can see, we have some items in the inventory and none in the hand. But if we click on one button, the item from the inventory disappears and that information is now on the hand. We actually pick up a thing. Because we test if the hand is empty first, we can click on the other buttons without changing or losing the item in the hand. So now we need to do the opposite. We have something in our hand and we need to put it back in the inventory. Stop the play and return to the script. Let's then add a condition where the hand is not empty. If hand is empty, pick up the thing, but else if and name is not equal to empty and items slot dot name is equal to empty, because we don't want to drop the thing inside an unused slot, we copy the item in the hand to the corresponding slot in the items array. Items slot equals hand. We reset the hands variable to the default state. Hands.name equals empty. Hands.count equals 0. And we run the method to update the interface. InventoryUI.updateUI. Save and return to Unity, and you should be able to pick stuff and put it back in the inventory. Now, to give some feedback to the player, let's stick the sprite of the item to the mouse cursor so it looks like you are really picking up the thing. Open the inventory script and add a sprite variable to the item struct. Public sprite. If you go to Unity, you can see the sprite variable empty, even if you play. So now, every time we pick up an item and add it to the inventory, we will also set this variable with the sprite of the object. In the addItem method, inside the if statement, where we really add the item, we also do items working slot dot sprite equals to object to add dot get component sprite renderer dot sprite to grab the sprite from the object we just collide with and add to the inventory. The next step is to have a sprite renderer following the mouse and update that image if we have something in the hand. So create an empty object, call it handSprite, reset the position and add a sprite renderer component. Create a new script called FollowMouse and add it to the new game object. Edit the script and code this inside the update. Vector3 screen point equals input.mousePosition. This will pick the mouse position to a vector3. ScreenPoint.z equals 10. This will offset the z coordinate to make it in front of the camera. And transform.position equals camera.main.screen to world point, open parenthesis, screen point, close parenthesis. This will move this object the sprite renderer according to the position of the mouse cursor. We need to operate this command because positions are in meters, but mouse coordinates are in pixels, and the screen to world point does the necessary math to adapt one system to the other. Anyway, the sprite should follow the mouse, but we are still missing one point. Add the correct sprite to it. Go to the inventory script and add a reference to the hand sprite object. Serialize field, sprite renderer, hand sprite. In the awake function, set the sprite to null, handSprite.sprite equals null. In the item button method, every time we pick an item, we add the sprite to the hand, and sprite.sprite equals hand.sprite. And every time we let go the item, we clear the sprite. handSprite.sprite equals null. Save, return to Unity and pick some objects. Now when you move them with your mouse, you can see the icon attached to the cursor. If you want, you can make the cursor's icon semi-transparent and set a different scale to help the player understand that the item is not in the world or in the inventory. In the next lesson, I'm going to program a way to use the items in our favor or against us. For example, could be something like charging the battery using the plutonium combined with the lithium, and maybe degrading the memory because of the radiation we carry when we have plutonium. This is just examples of two simple interactions between objects, and many others could be added later or not. At this point, I'm expecting to have just 2 more lessons, but that depends on the problems found during development. As I said before, I'm making the game as I go to show you also the process of experimenting with different solutions and the need to adapt old code to receive new features. Unfortunately, I don't have time to show you those tests that I delete every time. Well, that's how the thing goes. So, I hope you learned something new with this lesson, and I'm expecting to have you in the next one. Bye!